So Saturday morning, and we've been looking at Maltese cross experiment. What you've got here is some similar commission. You've got electrons being heated. Okay, that's where you can see this sort of light bulb-like glow. And then they're accelerated with an anode potential difference. At the moment, I'm on 2000. If I turn it down, you can see my fluorescence drops right off. And I've got a cross here, and that's connected at the top. It goes up and over, and I've got a positive connection here. Okay, and I've got a fluorescent screen. I'm going to turn the lights off. So you can now see the light bulb effect. And obviously as I go up with my accelerating PD, we get the green fluorescence. Now I'm going to move around to the front. I'll just show you what that looks like there. So that's when it's not working properly, or it's not on. And then we now have our, I'm going to focus in a little bit, our lovely Maltese cross. Let's get that centered. Now we can do a few cool things with that. I can use a magnet and I can push my electrons one way according to Fleming's Electron rule, or the other. So I'm pushing them away so they're not hitting where the fluorescence is, so it looks like the picture's moving. I can also take my magnet, and I'm getting away with the camera now, but you see the little swirl? So that's one way. Turn the magnet the other way, it swirls the other way. So that's the field lines going into or out of the direction here, backwards and forwards. And then we'll do something a little bit cool, and I'm going to take out my positive connection. So the positive connection that's on the cross itself, which at the moment is absorbing all the electrons. If I whip that one out, and let's turn it up a little bit, I'm now getting a build-up of electrons on the cross. There's nowhere for them to go now, it's isolated, which means that they, as the beam of electrons come towards the camera, I'm now obviously ending up with a bit of repulsion. And if I pop my wire back in, I should, hold on, I should get my sharp picture back again, because the electrons are streaming off the cross and disappearing. And the other final point to it is, here, effectively, the electrons are escaping as well from the surface. So it's, although it's an insulator, it's not perfect. So there you go, Maltese cross done in 2.5 minutes.